Oh, good day, everyone. My name is Master Ford from Science Mastery Center. Oh, sorry it took a long while before we come up with an educative video, very interesting video like this that might be of help to you. As you all know, we are experts in WAEC, JAM, science tutoring. So just click on the number on my bio for more inquiry or visit our page, visit our TikTok page, visit our YouTube page. All right. So last time we discussed the concept of isotope. We look at chemistry, but today I'm bringing something very, very exciting for you that very useful for you, especially people that are writing JAM and WAEC against 2026. And don't forget, we have started class already. Please do yourself a favor. The class has started since September. If you have not joined, you are really missing a lot. So just message the number on my bio so that you can ask for more inquiry and it can be put through. All right. So let's dive into what we have for today. So today I want to discuss the concept of electrical energy and power. As simple as this topic is, many people find it difficult, especially when they are faced with questions. They don't even know what formula to apply. So don't worry, your prayer has been answered. I'm going to demystify this in less than 7 minutes. I'm going to demystify this. So what I'm going to do first is this. I'll first give you all the formula that you'll be needing for this particular topic. Then after we have done with the formula and the derivation, then we can now dive into solving some questions, some WAEC and JAMB related questions. So sit back, let's go. Let's dive into what we have for today. All right, so we're having electrical energy and what? And power. First and foremost, let me give you the definition of what electrical energy is and what power is. Then I will dive into the derivation so that you can know the formula you use when you are faced with any question on this. Now, what do they call electrical energy? Electrical energy, just pay attention. Electrical energy is the energy transferred into a device or component when an electric current, all right, flows through it. So electrical energy is the energy transferred into a device or what component when an electric current flows through it. All right. Now, the work done in transferring energy into a device or component is given as this. W is equals to what? QV. So how we call this what? Equation 1. W equals what? QV. I will call this what? Equation 1. Now, let us analyze what each of these stand for, because we cannot just assume that, okay, W equals QV. Okay, what does this stand for? Now, let's go. I'm going to break it down for you. Your W is your what? Your work done. Work done in transferring what? Energy. All right? Your W equals what? Q. Your W is what? Your work done in transferring what? Energy. Your Q is what? The quantity of charges. The quantity of what? Of charges. Of charges measured in what? Coulomb. While your V is your what? Your potential difference. Your potential what? Difference. Measured in what? Volts. All right? Now, your work done in transferring energy is measured in what? Joule. So you have to take a look at this. All right? So I'll call this what? Equation 1. So let's move on. Now, from here, my Q, all right, is equals to what? IT. What does this IT stand for? This I stands for current, measured in what? Ampere. All right, measured in ampere. Why this stands for time? Remember, our time is always measured in what? Second. Do you understand it now? So I can say Q equals IT. If I say Q equals IT, I'll call this what? Equation 2. Please just follow this thing close. They are very simple. They are very, very simple. Remember, your work done in transferring energy to a device or component is given as what? QV. All right? And your W is your what? Your work done measured in joule. Your Q, the quantity of charges measured in coulomb. Your V is the potential difference measured in what? Voltage, right? So from here, W equals QV. So I can call this what? Equation 1. This is the first equation that should be on your mind. Now, moving on, your Q is equals to what? IT, current times time. Your current is always measured in ampere. Your time is measured in seconds. So I can say Q equals what? IT. I call this what? Equation 2. All right? Now, for us to manage this board properly, I can just divide something like this. All right? So that means I can say W equals what? In the place of this Q, I can actually put this IT. Is that not? IT, then V. So I can write this equation by saying W equals what? VIT. So I call this what? Equation 3. All right? Very simple. W equals what? VIT. Where your IT is your what? Your Q. Your V, potential difference. So this formula and this formula, they are basically the same. Reason why we are always giving you all of this is because there are some questions that you'll be faced with that you will need all of this knowledge. Do you understand that? So that you don't just put something on your head that W equals QV. So when they now give you question, you now solve question that has current and time. You are now wondering that what am I going to do? But it's only Q that I know now. Just know that Q is also equals to what? IT. All right, so this is equation 1. I call this equation 2. I call this what? Equation 3. Of course, you know what each of these, what they stand for. Your W, work done. Your V is your what? Your voltage. Your I is your current. And your T is your time. All right, so that is basically work done under electrical energy. Now, let's now move to power. Let's move to power. Let's move to power. Now, when they talk about power, it's very simple. It's nothing you should count. Power simply means the rate at which work is done. All right? Now, remember, we are looking at this with respect to what? Electrical energy and what? Electrical energy. Now, power. Your power is defined. Power is the rate at which work is what is done. The rate at which work is done is what they call power. That means P, power, equals what? Work done. Since we say rate at which work is done, work done over time. All right. Now, remember the formula that we derive for work done. We say work done, remember, is what? QV. Right? So that means in the place of this work done, I can actually put this QV. So let's go. I will now have power equals what? QV, which is your work done, over time. Right? Power equals what? QV over time. Where your P is what? Power. All right? Your Q, quantity of charges, remember? Quantity of charges. Your V is your voltage. And your T is your what? Time. This is second. This is V. This is what? Coulomb. Right? And this is also what? Joule. So power is the rate at which work is done. So let's move on. So I can clean this place now. Okay, so let me rewrite the equation for you so that you don't get it confused. So I will now have P equals what? QV over T. Remember, we stop at equation 3. So this will now be what? Equation 4. So I can as well say that P equals what? What's my Q? IT, right? V over T. So I can say P becomes what? VIT over what? T. Pay attention. This T will cancel this T, right? So I will now have P equals what? IV. This is equation 5. I call this what? Equation 5. Please pay attention to this. It's very simple. Many students get it confused. That's why you have to join Science Mastery Center. And we have started class already. Our class is very cheap, just for 8,000 naira only. You are good to go. Please join as soon as possible. Now your P is equals to what? IV, final equation. So I call this what? Equation 5. Remember our derivation, where we are coming from. Can you see it now? So anywhere you see question and they give you your current and they give you voltage, you are asked to look for power. Just substitute your value and then you are good to go. But there are some instances they will give you quantity of charges, voltage, and time. Substitute your value as well. You are good to go. You solve and you get your answer. So power is what? IV. Where I, of course, where I is what? Current. And V is equal to what? Voltage. These are very simple formula that you need. All right. So let's move on. We stop at equation 5. Okay, so let me clean this side. Let me clean this side. Now, since we already had P equals IV, and this is equation 5, remember what Ohm's law states. Ohm's law states that current passing through a metallic conductor is directly proportional to the what? To the potential difference, provided that temperature is kept what? Constant. Temperature and other factor is kept constant. Now, from V equals IR, I can bring out something from here. From V equals IR, remember Ohm's law, current passing through a metallic conductor is directly proportional to the what? To the potential difference. All right? Provided that temperature and other physical factors are kept constant. So from here, V equals IV, I can call this equation 6. Equation what? 6. Now, from this V equals IR, I can say P, which is the power. In the place of this V, what am I going to put? I'll put IR. Is that not? I'll just say I. Is that not? IR. Abi? So my power, okay, let me write it here. So my P, which is my power, can be equals what? I times I is what? I squared R. So this is also another formula for calculating what? Power. I call this what? Equation 6. Because many of you just see questions, they will ask you question and they will give you some values like this, and you are not confused. How am I going to I is power equals I square R? I'm giving you the derivative now. I'm giving you the derivation now. All right. So from your V equals IR with Ohm's law, so I can substitute this V for IR. So from here we have what? I square R. Because you can see question, they will just give you only current and the resistance. And they are now asking you to look for power, and you are now wondering that but the formula that I know is what? P equals IV. So where is where is R? Where is R coming from? I'm showing you where it is coming from now. It's coming from V equals what? IR. All right. So we already gotten about 6 equation now. All right. So power can also mean what? I square R. So please take note of this. Don't make mistake. Now I want to discuss another concept. They call it efficiency. Efficiency. Because when you are transferring energy into a component, some of the energy are lost in the process. All right. Some of the energy are lost in the process. Not all of the energy is being transferred into a component or devices. Some of them are lost in the process. So I want to have efficiency. Remember that efficiency is always measured in what? 100%. All right. So efficiency equals what? Useful work output over useful work input times what? Times 100%. So I can say efficiency, sorry, Efficiency is what? N useful work done. Work output, over what? N useful work input times 100%. So I can call this equation 7. Equation 7. So with this 7 formula I've given to you on electrical energy and power, there is no WAEC JAMB question that you cannot solve. That is why you have to join Science Mastery Center. With these 7 equations I've given to you, there is no question at all that you cannot solve on electrical energy and power. And I'm going to be solving some of the questions on this. We are going to be practicing some of questions on this, and we are going to apply all the formula that I've proved to you. We are going to apply each and every one of them in every question that we'll be solving shortly now. So let's just do a summary of everything that we have discussed here. So let's just do a summary. Now, the summary table, all formulas now. In summary, let's write out all our 7 equations. Equation 1, we have W equals what? QV, right? Sorry, let's have W equals QV. Equation 1, is that not? W equals VIT. Equation 2, all right? P equals what? W over T. P equals what? Q V over T. P equals what? IV. You remember? We call this what? Equation 3. V equals IR. V equals IR. We call this equation 4. We also said that P is equals what? I square R. We call this what? Equation 5. All right, which other one have we not proven again? We also said that Q equals IT. We can call this what? Equation 6. Then we say efficiency equals what? N useful work output over what? N useful work inputs times 100%. So we call this what? Equation 7. So with all this equation on electrical energy and power, there is no WAEC or JAMB question that you cannot solve. So in my next video, I'll be solving at least maybe 4 or 5 questions on this. So catch you in my next video. I remain Master Ford, the founder of Science Mastery Center. Do not hesitate to join. Class has started already. You are missing out. Thank you.